Welcome back to another CAD/CAM tutorial. In this video, we are going to create a 2D drawing file for this part using SolidWorks. This will be the final 2D drawing file for the part. This is what we are going to create. So we add the 4 views, the top view, the isometric view, a section view, and the right view. And then we add dimensions, be it angles, diameters, normal distances, inclined distances as well. And then we add notes, all dimensions in millimeters, all unspecified fillets, radius 3, chamfer 3 millimeters, symmetric. So we'll add these notes as well to the drawing part. Before we begin, I have a video where I modeled this part using SolidWorks and Siemens NX. So you can go and check it out. There's a link in the description if you want to know how to model this part using both SolidWorks and Siemens NX. And make sure to watch the video to the end. Leave a like on this video and subscribe, and turn on post notification so you don't miss any tutorial. And we can now begin. So we start off in the SolidWorks 3D modeling workspace. And this is our part that we are going to create the 2D drawing file for. So we have to go into the 2D drawing workspace. So come to this new, you can see make drawing from part or assembly. So click on it. And this is going to take us to the 2D drawing workspace. The first pop-up here, you can select the sheet. So we go with the standard sheet size and only show the standard formats. These are the standard sheet sizes, the A0, A1, A2, A3, and A4. So you are going with the International Standards Organization, the ISO standard. The A2 is what we are going to use. Okay. So this is our 2D drawing workspace. This is a view palette. To close the view palette, just click in any area. And then this is our drawing sheet. We have the title block here. To edit the content of the title block, just right click, edit sheet format. And now you can select the content of the title block, double click on it. And let's say this is SolidWorks 3D drawing. Click and then exit. So this is it. The first thing we are going to do is to add our views. So come to view palette. The views are no longer here. Refresh so they can come back here. And these are our views that we are going to insert. We first insert the isometric view. So come down, click on the isometric view, click, hold and drag, and bring it here. Again, view palettes. Then we add the top view as well. So click, hold the left mouse button and drag the mouse and bring the top view here. Okay. These views are too small for the drawing sheet. So move your cursor over the drawing, click on it, scroll down. You can see the scale of the view. You don't want to use the sheet scale, so use a custom scale. We are going with 1:1. This is too big, so 1:1.8, 1:1.2, and this is okay. I want to make it colored as well. So the isometric view, always make sure it is colored. So in the display style, you can use the shaded with edges and high quality. Okay. Then the top view as well, click on it, scroll down and then change the scale to 1:1.2. Okay. We are going to use the top view to generate a section view that cuts through the part. So come to the drawing, and then we have this section view. So we need a horizontal section view. So the cutting line should be horizontal, and then place the point in the center of the part. Okay, and move your cursor downwards. So this is the section view. Now I want to increase the text of the section view here. So uncheck this document font, click on the font, and then you can change the font type. I'll go with Verdana. The font style, I'll make it bold, and then the height of the text, I'm going to go with 8 millimeters. So yes. Now move your cursor over these section views, click on them, and you can see the text A. The section A has also increased in font. So this is it. And then we insert the right view as well. So click on the right view, hold the mouse and drag to this point. Okay. Now click on it, and then we change the scale to 1:1.2. Okay. So these are the 4 views we are going to work with. Next, we add the dimensions. The first dimension will be the outer diameter of the base cylinder. So come to annotations, smart dimension. You can zoom in and then click on this outer circle. You can see the dimension will automatically be generated. Click to release. But we can see the dimensions are too small. In order to increase the dimensions, come to settings, document properties. You can see the dimensions here. You can change the font. I'll maintain the Verdana font family. Make it regular. And the height of the text, I'll go with 7 millimeters. Now the primary precision, we don't want any decimals for our dimension, so make it none. Okay. So this size of the text is okay. Second dimension will be the height of the base cylinder. So we're going to do that on the right view. So click on this line and this line, and the height automatically is generated for you. Click to release. Next will be the full height from this line to this line. Will be 100 millimeters. We're going to insert a center line in this right view. So select view in the auto insert and then click on this right view. You can see the center line has automatically been added here. And then smart dimension, the angle of inclination between this inclined line and the vertical center line will be 20 millimeters. Now we can dimension the diameter of the base of the cone here. Smart dimension, click on it. That will be 120 millimeters. Then we can dimension the holes as well. So the distance from this line to this line will represent the diameter of the hole. And then distance from this line to this line will also be the diameter of this hole. Again, from this line to this line be the diameter of this hole. Then to get the length of this hole, just click on this line and then this line, 15 millimeters. Again, we can dimension the depth of this hole. So click on this line and this line. That will also be 15 millimeters. Now, since the full length is 100, this length is 15 and this is 15, automatically we can calculate the length of this center hole. So there is no need to add the dimension. And then again, for this feature, you can dimension the full length here, the inclined length here, And then the length from this point to this line as well, we can dimension. We can also have an angle between this horizontal line and this inclined line. That will be 20 millimeters. Again, the length from this line to this line, the inclined dimension, 6 millimeters. Okay. And we can see these holes here. We have to use the dimension. So I'm going to use the hole call out so that automatically every parameter of the hole will be dimensioned. So click on just one hole here, and we can see 10 times of the countable hole with these parameters. Again, smart dimension. The circle on which the centers of the holes are, we can dimension the radius to be 75 as well. And then for this feature here, we can dimension the angle between this line and this line. That will be 30 millimeters here. I think these are the necessary dimensions that we need. Any other dimension we add will be over dimensioning the drawing file. So these are what we need. Then we can add the notes as well. So you can see the notes here under annotations, notes. Click anywhere. You can change the font family to Verdana as well. Font size, let's say 10 millimeters, and make it bold. So all dimensions in millimeters, or unspecified fillets, radius of 3, the chamfer 3 millimeters and a symmetric one. This will be okay. Now click anywhere. You can see the notes still here. So click and then edit the text to top view. Come here, click, edit this text. Okay, so we don't need any text, but edit this one to right view. Escape. And then push the right view to the side. Okay. So we'll have another one here, which will be for the isometric view. So just click on this, Ctrl+C and V. That is a shortcut to copy and paste. So this will be the isometric view. Press escape, and that is it. So basically, this is the drawing file. We can thicken the visible lines, settings, document properties, come to the line font, and then we change the visible edges to a thickness of 0.7. Okay. So I think this will be okay. When we export the file, SolidWorks will reduce the thickness. So if we make sure the thickness is high, even if SolidWorks reduces the thickness, at least that will be okay. So in order to export the file, we can save the file before we export it. So the part 1's drawing, and save the parts. In order to export the part, come to the print command here, set up the page. We want to make sure the color or grayscale is visible, scale to fit. This is very important so that the drawing file can fit into one screen. Okay. And then okay. choose where we can save it. I'm going to save it in the desktop as part 1 PDF and save it. And you can go into the desktop. This is the part 1 PDF. I'll open it. And zoom out a bit. So this will be our 2D drawing file for the part. So yeah, that's how to create a 2D drawing file for this part using SolidWorks. That's the end of the tutorial. I hope this video helped you out. If it did, make sure to leave a like on this video and subscribe and turn on post notifications so you do not miss any upload. And I'll see you in the next one. Peace out.